Take your shoes off right now. If you can't, do it the moment this video ends. Not as a wellness ritual, not as a spiritual practice, as a physics experiment. Because what happens to your body in the seconds after your bare foot touches the ground is something Nikola Tesla spent the last decade of his life trying to explain to a world that thought he had lost his mind. He hadn't. He was just early, and the physics he was pointing at is only now being measured with the precision he always demanded. Let me start with something that will seem obvious and turn out to be completely wrong. You think the ground is inert. You think it is dirt or stone or grass, just material sitting there, passive, dead, doing nothing. That is not what the ground is. The surface of the Earth carries a net negative electrical charge. Not occasionally, not in storms, permanently. Right now, beneath the soles of your feet, the ground is holding an excess of electrons. A measurable, quantifiable, continuous electrical charge maintained by one of the most powerful and least discussed physics systems on the planet. Here is how that charge is maintained. At any given moment, there are roughly 2,000 active thunderstorms occurring simultaneously across the Earth's surface. Each one is a natural generator. Inside a cumulonimbus cloud, ice particles and water droplets collide in violent updrafts. The smaller particles carry positive charge upward toward the cloud top. The larger particles carry negative charge downward toward the cloud base. This charge separation builds until the electric field exceeds the insulating capacity of air, roughly 3 million volts per meter, and then lightning discharges. Not just cloud-to-ground lightning, cloud-to-cloud, intra-cloud, and the upward discharges that happen above storms that most people never see. Every discharge pumps charge through the atmosphere. The upper atmosphere, the ionosphere, maintains a strong positive charge. The ground maintains a strong negative charge. Between them stretches what physicists call the global atmospheric electrical circuit, a giant capacitor, planet-sized, continuously recharged by those 2,000 storms, holding a voltage difference of roughly 300,000 volts across 80 kilometers of atmosphere. You live at the bottom of this circuit. Every step you take, every time rubber soles insulate you from the surface, you are cutting yourself off from the negative pole of a planetary electrical system. And that matters enormously to your biology, for reasons that were not understood until very recently, and that Tesla understood intuitively decades before the instruments existed to prove him right. Tesla was obsessed with the Earth as an electrical conductor. This was not metaphor or mysticism. His Colorado Springs experiments of 1899 and 1900 were specifically designed to test the Earth's conductivity at scale. He had moved to Colorado Springs with a singular purpose. He believed the Earth itself could function as a transmission medium for electrical energy, and he needed a location where he could build a magnifying transmitter large enough to test the hypothesis at the frequency range he believed would resonate with the planet itself. The laboratory he built there was extraordinary. A wooden structure with a tower rising 60 feet, topped by a copper sphere 3 feet in diameter. Inside, a transformer system he called the magnifying transmitter, capable of generating voltages in the millions. His notes from Colorado Springs, which survive and have been analyzed by electrical engineers, show measurements of ground currents and atmospheric electrical conditions that no one else was systematically recording at the time. What Tesla was attempting was to exploit the fact that the Earth is a conducting sphere sitting inside an ionospheric shell, forming a resonant cavity. A resonant cavity has natural frequencies, just like a violin string has a natural frequency determined by its length and tension. The Earth ionosphere cavity has natural resonant frequencies starting at roughly 7.83 Hz. These are called Schumann resonances, named for physicist Winfried Schumann, who mathematically predicted them in 1952. But Tesla was working with this idea experimentally 50 years earlier. He wrote about the Earth's electrical charge, about the ionosphere as a conductor, about the possibility of resonant transmission. He was not inventing fantasy. He was doing physics in a frequency range and at a scale that no one else had the equipment to explore. Tesla also walked. He walked obsessively. His biographers and contemporaries document that he walked 8 miles every day in New York City, almost without exception, regardless of weather or schedule. He walked along the Hudson River, through Central Park, across Lower Manhattan. There is no direct documented statement from Tesla connecting his walking habit to the Earth's electrical charge. What we know from his writings is that he believed strongly in the connection between the human body and electromagnetic fields, that he saw the body as fundamentally an electrical system, and that he believed the natural electrical environment was important to biological function. Whether he connected his daily walks to barefoot grounding specifically, we cannot say with certainty. But the physics he spent his career exploring is precisely the mechanism now being studied under the clinical term earthing or grounding. Let me give you the mechanism in precise terms because this is where it gets remarkable. Your body is a conductor. Not a perfect conductor, but a conductive biological system. You are roughly 60% water, and water with dissolved electrolytes, the sodium, potassium, calcium, magnesium ions dissolved in your blood and cellular fluid, is electrically conductive. Your tissues conduct electrical current. This is not metaphorical. It is why an electrocardiogram works. The voltage changes produced by your heart muscle are detectable on the skin of your wrist because your body conducts those electrical signals from the source to the surface. Now, when your conductive body contacts a grounded conductive surface, electrons flow. They move along the electrochemical gradient from the region of higher electron density, which is the Earth's negatively charged surface, into your body. This is not a large current. It is not dangerous. It is the same physics as touching any grounded conductor. But its biological consequences are significant, and they operate through a mechanism that most people have never heard of. Your red blood cells carry a negative surface charge. This charge is called the zeta potential, and it is created by the distribution of ions on the outer surface of the cell membrane, specifically by the presence of sialic acid residues that hold negative charges at physiological pH. The zeta potential is not incidental to red blood cell function. It is central to it. The negative charge on each cell causes it to repel other negatively charged red blood cells, maintaining separation between cells in the bloodstream. This repulsion is what keeps red blood cells from clumping together, from aggregating into masses that would impede blood flow through the narrow passages of your capillaries. When your zeta potential decreases, when the negative surface charge on your red blood cells drops, the cells begin to aggregate. They clump. Blood viscosity increases. Flow through small vessels becomes impaired. This is measurable. It is clinically significant. And the zeta potential of red blood cells is directly affected by the electrical charge state of the body's aqueous environment, which includes the plasma and extracellular fluid surrounding every cell. In 2013, a study published in the Journal of Alternative and Complementary Medicine by Chevalier, Sinatra, Oshman, and Sokal measured zeta potential directly. Subjects were grounded for 2 hours, with measurements of blood taken before and after via dark field microscopy. The images are striking. Before grounding, blood samples showed significant red blood cell clumping, cells stacked together in what is called rouleau formation, like coins in a column. After grounding, the same subjects showed substantially reduced clumping. The zeta potential on the red blood cells had increased. The cells were repelling each other more effectively. Blood viscosity had measurably decreased from 2 hours of electrical contact with the ground. Now, I want you to think about what that means at the level of your capillaries. You have roughly 10 billion capillaries in your body. The smallest are 4 to 10 micrometers in diameter. A red blood cell is about 8 micrometers in diameter. These cells are squeezing through passages barely wider than themselves, single file, deforming their flexible membranes to fit. If those cells are aggregating, if they are sticking together even slightly, if their zeta potential is reduced and their tendency to cluster is increased, the physical resistance to blood flow through these tiny passages increases. Oxygen delivery to tissue decreases. Waste removal from tissue decreases. This is not abstract physiology. This is the difference between tissue that is well fed and tissue that is chronically slightly starved. The electron transfer mechanism from grounding directly addresses this by restoring charge to the conductive biological medium of your body. The mechanism is the same as discharging a capacitor. Your body has been accumulating a charge differential, depleted of electrons by chronic insulation from the ground, and contact with the Earth equalizes that differential. The physics is clean. The biology follows from it. But there is a second mechanism operating simultaneously, and this one involves inflammation in a way that most people fundamentally misunderstand. Inflammation is not a disease. It is a process. When your immune system identifies a damaged or infected cell, it deploys neutrophils, a type of white blood cell whose job is to destroy the target. Neutrophils kill through a process called oxidative burst. They produce reactive oxygen species, molecules with unpaired electrons, highly chemically reactive, that tear apart the membranes of bacteria and damaged cells. This is the weapon, and it is a very effective one. The problem is that reactive oxygen species do not have perfect aim. They are molecular shrapnel. They damage nearby healthy tissue. When the immune response is resolved, when the threat is neutralized, the body cleans up the reactive oxygen species using antioxidants, molecules that donate electrons to the reactive species, neutralizing their charge and stopping the damage. Here is the critical physics. Reactive oxygen species are molecules that are electrically positive, or more precisely, they are electron deficient. They have unpaired electrons and are seeking electrons to stabilize themselves. The antioxidants that neutralize them are electron donors. This is an electrochemical reaction. It is fundamentally about electron transfer. When your body is depleted of electrons, the balance between oxidative burst and antioxidant neutralization shifts. The reactive oxygen species persist longer. They do more collateral damage to healthy tissue before they are neutralized. This is the condition clinically called chronic low-grade inflammation, and it is the underlying mechanism implicated in virtually every major chronic disease: cardiovascular disease, type 2 diabetes, neurodegenerative conditions, autoimmune disorders. Not the inflammation itself, but inflammation that is not cleanly resolved because the electron supply for neutralization is insufficient. The Earth's surface is an electron donor of essentially unlimited supply. The ground is not going to run out of electrons. The global electrical circuit continuously replenishes the surface charge through the atmospheric discharges that are happening right now, at this moment, in dozens of thunderstorms across the planet. When your bare feet contact that surface, you are connecting your electrochemical system to an electron reservoir of planetary scale. The electrons available to neutralize reactive oxygen species increase. The resolution of inflammatory responses becomes more efficient. James Oshman, a biophysicist and cell biologist, has written extensively on this mechanism, describing the Earth as a global electron donor and connecting this to the documented anti-inflammatory effects seen in grounding research. It is important to be precise here about what is confirmed versus what is still being established. The electron transfer from Earth to body during grounding is confirmed physics. The increase in red blood cell zeta potential after grounding has been measured in at least one peer-reviewed study with before and after microscopy. The reduction in inflammatory markers in grounded subjects has been measured in several controlled studies. The specific pathway, that Earth electrons are directly neutralizing reactive oxygen species in tissue, is the proposed mechanism, and it is physically coherent and biologically plausible, but the direct causal chain from foot contact to reactive oxygen species neutralization has not been imaged or tracked in the way that, say, a drug molecule can be tracked through the body. The mechanism is supported by strong indirect evidence and physical reasoning. It has not yet been demonstrated with the same directness as the zeta potential data. This distinction matters, and I will not pretend otherwise. What has been measured with consistency across multiple independent studies is the effect on cortisol. The steroid hormone cortisol is your body's primary long-term stress regulatory molecule. Distinct from the fast-acting adrenaline of acute stress, cortisol operates on a daily cycle, highest in the morning to facilitate waking, declining through the day, lowest at night to permit deep sleep. Disruption of this cycle, cortisol that is too high in the evening, too flat in the morning, inverted relative to the natural diurnal rhythm, is associated with sleep disorders, chronic fatigue, immune suppression, metabolic disruption, and accelerated cognitive decline. A study by Ghali and Teplitz, published in the Journal of Alternative and Complementary Medicine in 2004, measured cortisol profiles in 12 subjects with sleep disorders, pain, and stress. They were grounded during sleep for 8 weeks using conductive pads connected to the Earth's surface outside the building. Cortisol profiles were measured before and after via 24-hour saliva collection. The results showed a normalization of the cortisol rhythm in the majority of subjects, not simply a decrease in cortisol, but a restoration of the natural diurnal pattern. Morning cortisol increased in subjects whose morning levels had been blunted. Evening cortisol decreased in subjects whose evening levels had been elevated. The curve moved back toward a healthy physiological shape. Subjective reports of sleep quality improved in all 12 subjects. Pain levels decreased in 11 of 12. This is a small study. 12 subjects is not a large sample. It was published in a journal that covers alternative medicine, which in some research contexts would be a flag for rigor concerns. These caveats are real, and I am not dismissing them. But the cortisol normalization finding is interesting precisely because it is not just a directional change. Cortisol went up or went down, but a pattern change. The shape of the daily curve moved toward normal. That kind of specificity is less likely to be noise. Subsequent studies have replicated directional cortisol effects in grounded subjects. The sample sizes remain small. This is an area where more rigorous large-scale research is needed, and where it is honest to say the evidence is suggestive but not yet definitive. Now let me take you back to Tesla, because there is a specific period in his life that is rarely discussed and that connects directly to what we are talking about. From roughly 1900 until his death in 1943, Tesla lived in New York City and gradually withdrew from active experimental work. The Wardenclyffe Tower project, his attempt to build a full-scale wireless energy transmission system, had failed financially. J.P. Morgan had withdrawn funding. Tesla spent his final decades in a sequence of hotels, most famously the New Yorker hotel where he died. He became increasingly eccentric in documented ways. He was obsessed with pigeons, particularly a white female pigeon he described in terms that alarmed his contemporaries. He had severe aversions to certain objects and textures. He ate with extreme restriction, eventually consuming little more than warm milk and honey and vegetable juices. But he kept walking. The 8-mile daily walks continued through his 70s and into his 80s. And throughout this period, He continued writing and lecturing, returning again and again to the theme of the Earth as an electrical system, of the importance of resonance with natural frequencies, of what he called the wheel of nature. In a 1919 article for Electrical Experimenter magazine, Tesla wrote about the importance of a human being's connection to natural forces. He described the Earth's electrical charge as a fundamental feature of the environment that living things had evolved alongside. These are not the writings of someone who had abandoned physics for mysticism. They are the writings of someone whose physics was ahead of the experimental tools needed to verify it. What Tesla could not have articulated, because the molecular biology did not exist yet, was the mechanism connecting the Earth's electrical field to cellular function. He could observe the effects, could reason about the physics, could intuit the importance of the connection. The gap between his intuition and the molecular explanation has been filled in across the last 20 years by research he never lived to see. Here is a mechanism he could not have known about, but would have found deeply satisfying. Voltage-gated ion channels. Your cell membranes are studded with protein structures that open and close in response to changes in electrical voltage across the membrane. These are called voltage-gated ion channels, and they are the electrical switches of your biology. When the voltage across a cell membrane changes, these channels open, allowing specific ions, sodium, potassium, calcium, chloride, to flow through the membrane along their electrochemical gradients. Ion flow is current. These channels are the mechanism by which neurons fire, by which your heart muscle contracts in coordinated pulses, by which signal transduction occurs throughout your body. Every electrical event in your biology runs through these channels. The voltage across cell membranes, typically around -70 millivolts for a resting neuron, is maintained by the sodium-potassium pump, an enzyme that actively moves 3 sodium ions out and 2 potassium ions in for every ATP molecule consumed. This pump is running constantly in every one of your cells, consuming roughly a third of your body's total ATP production just to maintain resting membrane potential. The charged state of your body's aqueous environment, the extracellular fluid, the plasma, affects the electrochemical gradients that these pumps and channels work against. Charge the environment differently. You alter the gradients. You alter the work the pumps must do. You alter the sensitivity of the voltage-gated channels. This is speculative at the level of specific direct causation from grounding to channel function. But it is physically coherent. The Earth's surface charge is real. Your cell's dependence on electrochemical gradients is real. The connection between the two, mediated through the conductive aqueous medium of your body, is the kind of mechanism that was invisible to everyone until the tools existed to see it. Just as the carbon in a tree was invisible to Van Helmont, even as it drifted in the air around his experiment. Tesla's Colorado Springs notebooks show him measuring ground currents and atmospheric potentials, with instruments he largely built himself. He was working in a frequency range, the extremely low frequency range below 100 Hz, that no one else was systematically investigating. The Schumann resonances he was unknowingly probing, those 7.83 Hz and harmonic frequencies of the Earth ionosphere cavity, are now known to closely match the frequencies of human brain waves. Alpha waves, the dominant pattern of relaxed wakefulness, occur at 8 to 12 Hz. Theta waves, associated with meditation and the threshold of sleep, at 4 to 8 Hz. The Earth ionosphere cavity resonates at frequencies that bracket the range of human neural oscillation. Whether this overlap is coincidental or represents a genuine evolved resonance between biological oscillators and the electromagnetic environment in which they evolved is not currently established. It is a hypothesis, but it is the kind of hypothesis that would have made Tesla set down his tea and start filling notebooks. Let me tell you what happens in the first 30 minutes of barefoot contact with the ground, based on what the current evidence supports. Within the first seconds, electron transfer begins. Your conductive body, previously floating at the ambient atmospheric electrical potential, which can be hundreds or even thousands of volts above ground potential, depending on your height and proximity to charged surfaces, equalizes toward ground potential. The physics is the same as grounding yourself before working with sensitive electronics. Your body discharges its accumulated static charge differential. This happens faster than you can feel it. Zeta potential changes in red blood cells have been documented within sessions lasting 2 hours. Cortisol changes accumulate over days to weeks. The effects appear to build with duration and regularity of contact, not all in one instant. Functionally, here is what barefoot walking on natural surfaces provides that shoes do not. Conductive contact with the electron-rich surface of the Earth. Not on all surfaces. Concrete is moderately conductive when moist, poorly conductive when dry. Asphalt is generally not conductive. Carpet is insulating. Grass, soil, sand, stone, and bodies of water are all conductive. The requirement is for your skin to be in actual electrical contact with a surface that is connected to the Earth's charge reservoir. This is why grounding research uses conductive pads connected via wire to a ground rod outside the building. The wire maintains the electrical connection regardless of what the floor surface is. When you walk barefoot in the grass or on a beach or through wet soil, you are creating the same connection passively. Tesla spent 40 years trying to harness the Earth's electrical field for transmission. The irony is that the most elegant demonstration of its biological importance required no technology at all, just the removal of a shoe. There is a second physics operating when you walk barefoot that is completely separate from the electrical mechanism and that almost no one discusses. It is mechanical, and it starts with the structure of your foot. The human foot contains 26 bones, 33 joints, and over 100 muscles, tendons, and ligaments. It is a mechanical marvel of layered arch structures. The medial longitudinal arch, the lateral longitudinal arch, and the transverse arch create a three-dimensional spring that compresses under load and rebounds, absorbing impact energy and storing elastic potential energy in the tendons and fascial structures that span it. The plantar fascia, the Achilles tendon, the spring ligament, all function as elastic storage elements in a system that is extraordinarily energy efficient when it functions as designed. The foot was designed, by which I mean shaped by 4 million years of bipedal locomotion, to function without an artificially raised heel. The natural standing position of the unshod human foot has the heel only slightly elevated above the forefoot, perhaps a few millimeters, by the padding of the heel pad itself. Modern shoes typically place the heel 2 to 4 centimeters above the forefoot. This heel elevation shifts the body's center of mass forward and up, which in turn shifts the mechanical demands on the entire kinetic chain of the lower limb, the ankle, the knee, the hip, the lumbar spine. Walking barefoot on natural surfaces, which are irregular in ways that manufactured floors are not, activates the foot's intrinsic musculature continuously. The small muscles inside the foot itself, the flexors and abductors of the toes, the intrinsic arch muscles, must work constantly to adapt to surface variation. In shoes, particularly in highly cushioned or rigid shoes, this adaptation is outsourced to the shoe structure. The muscles atrophy from disuse. The arch stiffens. Proprioception, the foot's sense of its own position in space, diminishes. Proprioception is not a luxury. The mechanoreceptors in the sole of your foot, Meissner's corpuscles, Pacinian corpuscles, Merkel's discs, Ruffini endings, are continuously sending positional information upward through the spinal cord to the cerebellum and the sensoromotor cortex. This information is used for balance, for gait coordination, for the fine adjustments that keep you upright on uneven terrain. Reducing proprioceptive input from the foot does not just affect balance. Research in postural control has shown connections between foot sensory input and muscle activation patterns all the way up through the hip and core. The foot is a sensory organ, and treating it as a wheel by sealing it in a rigid shoe reduces its sensory output substantially. A 2017 study of Kenyan children, some of whom wore shoes regularly and some of whom did not, found that the unshod children had significantly greater arch height, wider feet, and better performance on balance and agility tests. A study comparing foot morphology in populations with and without habitual footwear found that habitually barefoot populations had stronger arch structures and larger foot muscle cross-sections. The mechanical use it or lose it principle applies to the foot exactly as it applies to every other musculoskeletal structure in the body. When Tesla walked his 8 miles through New York City, he was wearing shoes. There is no evidence that he walked barefoot, but the hours of daily walking, the loading and unloading of the foot's mechanical structures, the proprioceptive engagement, the rhythmic mechanical demand on the cardiovascular system were real and measurable in their effects, regardless of what he wore on his feet. What the electrical grounding research adds to this picture is that walking in places where bare contact was possible, grass, soil, the beaches of the Hudson, would have added the electron transfer mechanism on top of the mechanical one. Tesla's diet habits in his later years are documented and somewhat alarming. He restricted his food intake to the point of clinical concern. He ate alone, disdaining company at meals. He consumed primarily liquid. He lived until 86 despite this, in an era when the average American life expectancy was significantly lower. His longevity in the face of what by any modern nutritional standard was a deeply inadequate diet has been attributed by his biographers to his robust constitution. The physics-minded might also note that he lived in a city he walked through daily, in hotels where he was grounded through the building's electrical systems, doing mental work that maintained continuous neural engagement. None of this is sufficient to explain his longevity with certainty. Human lifespans are determined by so many interacting variables that single-factor explanations are almost always wrong. But it is worth noting that the man who spent his life convinced of the body's fundamental electrical nature also maintained one of the most consistent electrical connection habits available in early 20th century urban life: 8 miles of walking every day. Here is what the physics tells you to do with this information, and what it does not tell you. The evidence for electron transfer from grounded surfaces into the body is good physics and has been confirmed at the level of blood cell behavior in controlled conditions. The evidence for anti-inflammatory effects from grounding is suggestive across several small studies. The evidence for cortisol normalization is interesting and specific, but needs replication at larger scale. The proposed mechanisms connecting all of these, electron donation to reactive oxygen species, voltage-gated channel sensitivity modulation, are physically coherent and biologically plausible, but not yet fully established as causal chains. This is the honest summary. The effect is real. The mechanism is partially established and partially proposed. The magnitude of clinical significance for healthy people in ordinary life is not yet precisely quantified. What this means practically: 30 minutes of barefoot contact with conductive natural surfaces, grass, soil, wet sand, per day is the duration used in most of the research showing measurable effects. This does not require a forest or a beach. A lawn works, a patch of soil works. The key variables are conductivity of the surface and direct skin contact. The effects appear to be dose-dependent in some studies, meaning more time shows larger effects. But even brief daily exposure shows some measurable outcomes. What it does not mean: this is not a treatment for any specific condition. It is not a substitute for medication or medical care. It is a physics-based exposure to a natural feature of the electromagnetic environment that human biology evolved alongside and from which modern life has progressively insulated us. Whether framing it as restoring a lost natural exposure or as a novel therapeutic intervention, the underlying physics is the same. Tesla spent the last years of his life in a hotel room with pigeons, mostly forgotten, working on what he called the dynamic theory of gravity, and writing increasingly abstract papers about cosmic energy and the fundamental nature of force. The scientific establishment had largely moved on from him. The frequencies he had worked with at Colorado Springs were classified by the military. The resonance phenomena he had observed were not systematically studied until decades after his death, and the biological implications of the Earth's electrical charge were not seriously investigated until 50 years after he was gone. What is strange is that the thing Tesla could not get anyone to pay attention to, the Earth as an electrical conductor of biological relevance, is now being studied in medical schools and published in peer-reviewed journals. Not in the grand form he imagined, no wireless transmission of power across continents, but in the quiet, repeatable, measurable form of red blood cells photographed through a microscope before and after 2 hours with feet on soil. He walked 8 miles a day. He believed the body was fundamentally electrical. He believed the Earth's charge was biologically relevant. He could not prove it with the instruments of his time. The proof he could not make is being made now, not with the towers he built in Colorado, but with something far simpler and far older than any technology he ever touched. Take your shoes off. Not because Tesla walked barefoot, he didn't, or not that anyone recorded. Not because nature is healing, or because the Earth has intention. None of that is physics. Take your shoes off because the ground beneath you carries an electrical charge maintained by planetary thunderstorms, because your red blood cells carry surface charges that affect blood viscosity, because electrons flow from regions of higher density to lower density along gradients that follow the same laws in your body that they follow in every conductor in the universe. Take your shoes off because you are a conductive biological system that has been floating above a charge reservoir on rubber-soled insulation for your entire adult life. Stand in the grass for 30 minutes. Nothing mystical will happen. What will happen is electrons will move. Gradients will equilibrate. Some things in your blood will change in ways that instruments can measure. The world will look exactly the same. The physics will have operated anyway. It always does. You just might not have been paying attention. Tesla was paying attention for 40 years with instruments he built with his own hands in a field in Colorado. And what he was listening to was, in the end, this quiet. The charge beneath your feet. The circuit running overhead. The body standing between them. That is not poetry. That is the global atmospheric electrical circuit, and you are standing at its negative terminal right now.